This is Lesson 4-3A from the Algebra Readiness textbook. For today's lesson, you will need your notes packet and a sharpened pencil. Gather your supplies and work the study guide problems on your own. Then continue the lesson when you're ready to compare your work to mine. The first question asks us to write using exponents. I see that there is an x repeatedly being multiplied. There are 4 x's, so x is my base and 4 is my exponent. Then y is being multiplied by itself 2 times, x to the 4th, y to the 2nd. The next one, a microscope can magnify a specimen 10 to the 3rd times. How many times is that? 10 to the 3rd is the same as 10 times 10 times 10, which is 1,000 in standard form. Number 7, or simplify 8 plus 2 to the 2nd power plus 6. The first thing I need to do is simplify the parentheses, my grouping. Inside the parentheses, I need to use the order of operations. So before I would add, I need to simplify the exponent. 2 squared is 4. The next step is 4 plus 6 because it's inside the parentheses. 8 plus 10 is the last step using my order of operations, and I get 18. Okay. For today's lesson, our learning target is to use prime factorization to find factors. First, let's go over some vocabulary. What is a prime number? A prime number is an integer greater than 1 with exactly 2 positive factors. Exactly 2 factors. 1 and the number itself. Those, what I've highlighted, is the most important part. 2 is prime because 1 times 2 are the only 2 numbers that go into 2. 3 is divisible by only 1 and 3. 5 is divisible by only 1 and itself. 7 is divisible by only 1 and itself. So these numbers are prime. There are many others. Composite. A composite number is a number greater than 1 with more than 2 positive factors. So for example, 4 is divisible by 1, by 2, and by 4. 6 is divisible by 1, 2, 3, and 6. So it's not just 1 and itself. There's many. 1, 2, 4, and 8. 9 is divisible by 1, 3, and 9. 10 is divisible by 1, 2, 5, and 10. These are just a few examples. There are many, many more. Please note that 1 is neither prime nor composite. By definition, a prime number has exactly 2 factors. The only number that 1 is divisible by is itself. So that means there's only 1 factor, so it is not prime. And by definition, a composite number has more than 2 factors, and 1 does not have more than 2. So we say that one is neither. State whether each number is prime or composite. Explain. Because 23 is divisible by only 23 and 1, it is prime. My explanation is that it has 2 factors, 1 and 23. 129 is composite. All I need to prove is that it has more than 2 factors. So I know that 1 and 29 are factors, and using the divisibility rules, I know that 9 plus 2 plus 1 is 12, and 12 is divisible by 3, so 129 has a factor of 3. I don't even need to do any more work than that because it's composite if it has more than 2 factors, and I was able to list 3. Which of the numbers from 10 to 20 are prime? Which are composite? Pause the video and sort the numbers between 10 and 20. Then come on back to compare your answers to mine. All right, the numbers between 10 and 20 that are prime are 11, 13, 17, and 19. They all only have 1 and itself as factors. The numbers that are composite are 10, 12, 14, 15, 16, 18, and 20. Moving on, prime factorization is writing a composite number as the product of its prime factors. We're going to use a factor tree. Let me do this for you. You want to write everything above the red line in your notes. We're going to use a factor tree. Make sure that you write the factors in order from smallest to largest and use exponents to indicate your repeated factors. Use a factor tree to write the prime factorization of 825. So, 825, you write that first. Because 825 ends in 5, I know that 825 is divisible by 5. So 5 times 165. As soon as one of the factors is prime, we're going to circle it. Because 165 ends in 5, I know that it's divisible by 5. So 5 times 33. 5 is prime, so I circle it. 33 is divisible by 3 and 11. 3 is prime and 11 is prime. So the prime factorization, written in order from smallest to biggest, is 3 times 5 times 5 times 11. But we want to use exponents when we have repeated factors. 3 times 5 squared times 11 is the proper format to write a prime factorization. All right, let's try one more together to make sure you have it, and then we'll let you try some on your own. 72. 7 plus 2 is 9, so I know it's divisible by 9. 9 times 8 is 72. 9 can be broken down into 3 times 3. 8 can be renamed as 2 times 4. 3 is prime, 3 is prime, 2 is prime. Now I just have to work on that 4. 2 times 2. So the prime factorization is 2 times 2 times 2 times 3 times 3. So 2 to the third power times 3 to the second power. 121 is the same as 11 times 11. 11 and 11 are both prime. So my answer is 11 squared. All right, pause the video and try the next 2. Come on back to compare your answers to mine. $225 can be written as 5 times 45. 5 is prime. 45 is the same as 5 times 9, and 5 is prime. 9 is the same as 3 times 3, and the 3's are prime. 3 squared times 5 squared. The last one, 236. I see it's even, so I can go 236 divided by 2. And you probably had to do a side problem, and you got 118. 2 is prime. 118 is divisible by 2 again, and it equals 2 times 59. Now, I'm guessing you tried many different things to figure out if 59 was prime, and it is. 2 squared times 59 is the prime factorization for 236.